Ahoy sailors, Captain Mo here. I'm so glad you could join me for week 2, all about buoyancy. Do boats sink or do they float? If you answered sink, you're right. And if you answered float, well, you're right too. So how does a boat that was once afloat end up at the bottom of the ocean? To answer this question, we need to know something about density. Density is mass per unit volume of an object. What does that mean? Mass is how much matter is in something, or how much stuff is in that object. Imagine a pillow filled with feathers. And now imagine a brick. You probably only want to have a pillow fight with one of those. A pillow filled with feathers is less dense than a brick. Volume is how much space an object takes up. And density is how much stuff is in that space. Imagine you had an empty container and you had this same size container filled with water. Which one is more dense? You guessed it. The one filled with water is more dense. What's more dense, land or water? Land is more dense, and you don't have to worry about sinking while you're on land. Water has a certain density. If you looked at water underneath a microscope, you could see how close the molecules of water are to each other. Molecules are the things, the teeny tiny things, that stuff is made of. If an object is less dense than water, the object will float. If the object is more dense than water, the object will sink. And if the object has the same amount of density as water, it will hover near the surface. Fresh water is less dense than salt water because there's salt also in salt water. So in theory, fresh water should float on top of salt water. Let's find out if that's true. This experiment, I'm in my bathtub because I might spill something. For this experiment, we'll need 2 cups of the same size, 2 index cards, 2 more cups of the same size for experiment number 2, something you can use to mix, food coloring, I picked blue and yellow, some salt to make salt water, and a measuring cup to pour water into your containers. Go ahead and pour water into each of your containers, all the way to the top. Well, maybe a little bit underneath the top, so it's not spilling over. For experiment number 1, we are going to see if fresh water will float on top of salt water. I'm going to make my salt water using blue dye. And salt. A little taste. Yep, it's salty. Now, time to make fresh water. Well, this water's already fresh water. It's just tap water. but I'm going to put yellow into it so I can see it a little better.
Here we go. If my theory is correct, the fresh water will float on top of the salt water. That means the yellow water should stay separate from the salt water, from the blue water. They shouldn't mix. Fingers crossed for this and I don't spill. Alright. So carefully place my fresh water glass on top of the saltwater glass, opening to opening. And then very carefully and slowly, keeping the opening of the mouths of the containers lined up, I remove the index card. Alright, phew, and voila! The fresh water is floating on top of the salt water. No mixing. Alright, let's move on to the second experiment. This time, instead of fresh water on top of salt water, I'm going to put the salt water on top of the fresh water. How will this experiment be different? Instead of putting the yellow on top, I'm going to put the blue on top. Let's make some salt water again. And we'll put yellow food coloring into the other jar to identify that it's fresh water. So, if salt water is more dense than fresh water and I put it on top, in theory, it should sink. And my colors will mix. Here we go. Index card on top of the jar, flip it over, carefully slide it on top. And this takes a little bit of practice. This is my third time at it without spilling everywhere. Dense salt water on top, less dense fresh water on bottom. When we remove the index card, the salt water on top starts to fall, and the waters combine, they mix. Mixing yellow and blue, we get green. So our theory was correct. Fresh water is less dense than salt water and floats on top. All right, your turn now. You can pick any colors you'd like.
If a boat is less dense than the water that it sits in, it will float. But if the boat is more dense than the water that it sits in, it will sink. So then, how does a ship made out of metal carrying thousands upon thousands of pounds in cargo float when the screwdriver that I was using to fix my boat sank to the bottom when it fell overboard? This is where the amazing mathematics and science of engineering comes into play. It's all about the shape. If that big metal boat was squashed up into a wad, kind of like a piece of paper, it would sink. But the boat is designed to hold air. And we know that air is less dense than water. That's why when you swim down to the bottom of the pool and blow bubbles out, the air rises to the top. So, all of you boat builders and engineers out there, let's look at some hull designs. The hull is the name for the body of the boat. Boats are built for different purposes. Some boats are built to carry a lot of weight, a heavy load, like barges or cargo ships. Other boats are designed to go fast, like racing boats, like this America's Cup catamaran. Pick a couple hull designs that you think would be good for carrying a heavy load. Grab some foil and have fun designing at least 2 boats. Find some pennies and count how many pennies you can fit in each boat. See which design is the best for carrying a heavy load. Once you're done with your experiment, take your boats and fold them up, trying to make them really flat, trying to get all the air out from any cracks in it should sink. So a boat that's afloat is positively buoyant. It is designed to hold air. It has air compartments that keep it afloat. If that boat fills with water, gets a hole in it, and those air compartments start filling up with water, then that boat begins to sink. It becomes negatively buoyant if it sinks. How about humans? Are we positively buoyant? Do we float? Do we have air compartments? Go like this. We have 2 air compartments. Our lungs hold air, and that helps us float. What else could help us float? How about a life jacket? A life jacket helps us become even more buoyant. So, next time you head out to the water, don't forget your life jacket. Thank you so much for joining me for this week all about buoyancy. I can't wait to meet up with you on Thursday at 4 p.m. on Zoom. Keep an eye out in your email for a link to join. Captain Mo out.